So our goal for today's lesson, now that we've spent all this time graphing parabolas, we have to go backwards. So given a parabola, we're going to write a quadratic equation for that parabola. So again, it is super helpful to have your what I need to know about parabolas handout handy when you go through and write your equations. So, you know, on your test next week or even in some of the word problems, you might be looking at a parabola that looks like example 1. And they're super nice to you here in the directions. They say, hey, write a quadratic function in vertex form. You see that? So you might look at your pink paper if you don't have it memorized already. And you're like, oh, vertex form, I know what that is. I'm supposed to write an equation of the form y equals a times the quantity of x minus h squared plus k. In all honesty, when I've made these test questions in the past, I will go ahead and let you know that I am not quite so nice. I just say write an equation for the parabola that's given, because I want you to think about the form that would fit. So let's have a conversation right now about why your textbook editors here chose vertex form for this parabola. Eric. Yeah, you're given the vertex. Good eyeballs. So, see that right there? That minimum value on our parabola is what we call our vertex. If they give you the vertex, vertex form is going to be the easiest one to write. You see that? Are you making that connection? So here, it's nice because they're giving you your h and your k value already. So after I establish what form, I start filling in the pieces that I know in an effort to solve for what I don't. So here's me filling in the pieces that I know. Right now, I know that h is -2 and k is -3. And now I'll just bring down the rest of the equation around it. So I'll bring down my y equals a x minus a -2 squared plus my k value. What you might notice is that this could be neatened up a little bit, because when we minus a minus, that is ultimately a plus. In math class, it's pretty rare that I give you a piece of information that you won't use in the problem. So there's a piece of information that's given, and I could definitely use it to help me solve for what I don't know, the a value. Joey, what are your thoughts? Yeah, how am I going to use it? Do you have any ideas? I will. This when they give you the y-intercept, they're giving you a point. And as Joey's sort of indicating, he understands that when they give you a point, they're giving you an x and a y value. So we could let x be 0 and let y be 5. And then I could plug that in to solve for a, the other piece that I do not yet know. So I'm going to go ahead and set that up. My y value is 5. My x value is 0. And again, I'll bring down the rest of the equation around it. And then I'm going to use this to solve for a. Annalise, I saw you had your hand up. What's up?
Would you use the 2 points to make a slope?
The pattern from here to here isn't linear. So it's not like we can do y2 minus y1. That's a good thought, though. If this were an absolute value function, for sure that's what you would do. But the pattern or the rate of growth from here to here isn't necessarily linear. That's our squaring pattern that maybe you observed a couple days ago on our graphing T-chart worksheet. So yeah, now I'm going to go ahead and solve for a, get a by itself. I do, you know, you might recall from chapter 1, if you're going to go ahead and solve this equation for a, you have to simplify both sides first. So I'm going to simplify a little bit. 0 plus 2, that's 2. 2 squared, I'm going to have to do that too. So a times 4 minus 3. A lot of my students, so not a lot, who am I kidding? Not very many at all. Some of my students will make a mistake at this point in time, so just be careful. Am I allowed to subtract this 4 minus 3 right now? No, so watch out for that. I'll see it every once in a while. If you're a person who was tempted, oh so tempted right now to subtract 4 minus 3, I would encourage you to write that almost in a linear form. So you could rewrite it as 4a minus 3, and that'll prompt you to add 3 to both sides. So we're sad mapping now. 5 and 3 is 8. And then I still have 4a left over on the right side of my equal sign. 4a is the same as 4 times a, so to undo the multiplication, I would just divide both sides by 4. And so a is indeed 8 divided by 4, which is 2. So now that I know a, h, and k, I can completely write my equation. So that's what I'm going to do. My last step is to just solve the problem, answer the question. We have y equals, my a value is 2, x plus 2 squared minus 3 would be the equation for this parabola. And you could check it by throwing it into your calculator. Press the table. The points that are on that parabola should match the points on your table. The picture should match the picture on the graph. So this is very checkable. Questions about that? You good back there? Y'all good? When you say simplify, what were you thinking? You can't do that. You'd have to FOIL x plus 2 first. So you'd FOIL and then distribute. You could switch this into standard form. That's a nice thought, but it said vertex form, so that's why I'm done. But you would FOIL x plus 2 times x plus 2, distribute your 2 in, and then subtract 3. All right, one more. Example 2 says this time, hey, write an equation in intercept form. Again, that's very kind of them to say what form. But on your test, it doesn't say what form. You have to kind of think through that a little bit. So let's have that discussion. Eric helped us out last time. He did a nice job. Why is, so he's kind of off the hook for this one. Why is this a nice situation where intercept form would be handy? Ooh, look at all those hands. Go ahead, Abby. There's 2 x-intercepts. Very good. So here's what Abby sees. Abby sees this, and she sees this. We have 2 intercepts, so intercept form is going to be super handy. When they give you your intercepts, they're actually giving you your P and your Q. Just to recall, if you need your pink paper, intercept form right at the top goes y equals a x minus p times the quantity of x minus q. So I now can take just a moment to fill in my p and my q. So I'll sub in -3 for my p, and 2 for my q. If you wanted to pretty that up for a second, you could. Minus a -3 is x plus 3. They do give me another point to use, right? So remember how to solve for your a. You're going to take this, bless you, this x and y that they give you in the problem, bless you. So x is -2 and y is -4. You're going to take those values, plug them in, solve for a. Oh my, bless you. What's up? It doesn't. And if you think about it, multiplication would be commutative, so the order in which I put these parentheses, even back to factoring, doesn't really matter. Good question. I'm going to go ahead and take my x and plug it in, and my y and plug it in. Y in this case is -4. X is -2. Be careful, it gets plugged in both spots. And then I'll bring down the rest of the equation around it. And then again, if I want to go ahead and solve this equation now for A, so if I want to get this A by itself, I have some evaluating to do. Again, step 1 back in chapter 1 when we solved is you have to simplify both sides if you can. So I can simplify that right side a little bit. The sum of -2 and 3 is going to be 1. And then -2 and -2 is -4. So what I get there is -4 equals A times, and then 1 times -4 is -4. Using my Mad Algebra 1 skills, I know that to undo this product here, I just need to divide both sides by -4. So A in this case is actually 1. We know multiplication by 1 doesn't necessarily explicitly need to be written, but you can pop your 1 in there if you'd like. So finishing up our problem, we were asked to write an equation in intercept form. So A is 1. Our first intercept there was -3, so that gave us x plus 3 as our first quantity. And then our second intercept there was at 2, so that gives us x minus 2 as our last quantity. That is how you look at a parabola when you're given two x-intercepts and write an equation in intercept form. Questions about the process? Because now you get to try. So you have 2 independent practice questions there at the bottom. I'm going to walk around and start checking off a little bit of that homework that you did last night, that 4-2 practice B. I'll show you the answers to these in just a moment. So I did want to take a second just to show you your answers to your independent practice conclusion questions. So could you take a second, just make sure you have those right. It looked good as I walked around. Nice job, you're getting this. Number 1 is y equals 2 times the quantity of x plus 2 times the quantity of x minus 1. It's my sincere hope that you are able to recognize that if they're going to give you 2 intercepts, that you used intercept form there. Number 2, they gave you the vertex, so vertex form is going to be the way you want to do it. You get y equals 3/4 times the quantity of x minus 2 squared plus 1. I will go ahead and let you know that there won't be any problems on your test or even on your homework tonight where they don't either give you one or the other. So if they give you like 3 random points on a parabola, we'd actually have to do that a different way. You might recall that we did a while back something called linear regression. There's quadratic regression too. So there is a different process that we go through if other parts of your parabola are given. They can take care of that in your stats class if they get to that. Some of you, I heard, are taking that either now or next semester, so you might get to see that. Before I go ahead and finish checking homework and talking about your pink paper there, what I need to know about parabolas, did anybody have any questions about our lesson today or about your independent practice? Get a little bit of book work tonight. It should be pretty quick, I think. So with that,